go here. Good.
Professor, I have one question.
Yes, go ahead, please.
It says in the syllabus, it mentioned that we have one project and it should be available from 9th of November.
Yeah, yeah,
So
yeah.
yeah, I just want to
I
ask
know.
about that.
Probably you joined the class little late. I already addressed that because I want to cover little more material before posting the group project instruction.
Sure.
Um, um, because we have 2 consecutive long weekend, I'm really behind with this course. So, but although I know time is running out, we are in 11th week now. But I'm not going to give any big project that you have no time. I understand that. So don't worry about that, okay? But I want to do one thing actually. Thanks for asking this question. Let me do that first. So if I go here, go here. I guess that's enough, but I can make another 40. That's enough, I guess. I believe you know each other, and I want you to put your name, 3 names, whatever your choice. I'm not forcing you who will go in which group. Put your name here, like 3 people. If someone started to feel it, I'm going to share this file, don't worry, not now. So let me save and share this. Share. manage access. And to give sharing, and to give access to edit. Keep it. Now we can edit. All right, so copy and can save this. All right. So let me go into 11. I'm going to set URL. Groups file. I'm going to give this URL here. Post it. All right. So I believe everybody can see this link here. And to make sure it's visible. So if you click here, and if you click here, you have to log in with your CBU ID. So please put 3 names of your choice here so that we all, I will get all the group members, right? So say if you don't know anyone, then put your name in one of the bottom columns so that I can tag you with other people. All right. I know we live in an online world. We may not know each other, have difficulty to forming groups. Put your name in the bottom in a single column so that I can tag with anyone with the group. So you can put your name here. Anyone can start. If anyone choose a column, please do not write over. We can choose another new column, say here, right? So that we can have our group and group members. So it will be easy for us. All right, so if you started to feel, we can actually see. You can write your name here, name 1, right? Name 2, whatever. You can start putting your name, okay? All right, so that's I'm looking for is someone's group is ready, then you can put one so that we can see how other can put their names. If your group is not ready, that's fine. You can take time because I have not posted the group project instruction, so you can take time to fill it. But I know you will forget, so I actually want you to fill this file as soon as possible. All right, good. Now let me. It will be transparent and free so that everybody can see this. All right. Let me, you can consult and help yourself on that. Let me go back to the lesson.
So maximum
right.
of 3, right?
Yes, please, no more than 3 and no more than based on the class size, whether we are odd or even. One group might be 4 or 2, but yes, 3 is the standard. See, so everybody can see it, right? We can carry on like this. Okay, good. So let me go back with, so in our last lesson, we cover till binomial, I guess, distribution. So we ended our class with this slide, shapes and skewness, right? So our goal is to start Poisson. And you know, like every distribution that we had that has a probability mass function, PMF. And Poisson distribution is not an exception. Poisson distribution also has a probability mass function. So let's read what is Poisson distribution.
Models the number of occurrences in some unit of measure, often time or distance. There is no limit on the number of occurrences. The average number of occurrence per unit is a constant.
Right. So the main theme is number of occurrences. So number of occurrences could be a customer, any event. So there are a lot of practical aspects of Poisson distribution, and Poisson distribution is one of the famous and mostly used statistical distribution. So let me go back to your textbook. I was reading because I was reading for give you some practical examples so that it will be easier for you to understand those things. Let me see in chapter 5, and we are looking for distributions. Chapter 5. Yeah. Poisson distribution. And in Poisson distribution, you can see the Poisson distribution is a discrete distribution. So discrete is not continuous variable. Used to model the number of occurrences in some unit of measures. For example, the number of customers arriving in a Subway store during a weekday lunch hour, number of failures of a machine during a month, number of visits to an website. So it's there are a lot of different aspects, and sometimes slide does not cover those. That's why I'm showing you here that what are those practical use of Poisson distribution. So there are, it counts the number of events, number of occurrences. That's Poisson distribution, right? And you can see here, there is an example that an average number of customers arriving at a Subway during Subway is the Subway is the store for fast food store, right? And you're familiar with that. Lunch over 12 customer per hour. The probability that exactly X customer will arrive during the hour is given by a Poisson distribution with a mean of 12. Probability that exactly X customer will arrive during the hour would be calculated using the formula, right? And say if we execute 12 with 5, you will certainly get a different Poisson distribution, right? And Microsoft Excel has a built-in function for Poisson distribution. So this is the PMF for Poisson distribution. You can see here. Who is not familiar with this type of equation? Probably you all are. So e to the power minus lambda into lambda power to the x, and you can see this courtesy here. Lambda is the expected value, and expected value equal to lambda and variance equal to lambda. That's a little confusing. That should not be. Let me go back to the textbook. Here, so there are two kind of lambda. See, this lambda is not quite clear. There is a small lambda and there is a large lambda. That's why I got confused. So you have to be careful with those. But in this example, okay, all right, I get it. No, it's the same lambda because by analyzing this example, you can see all are 12. So in case of Poisson distribution, expected value and variance are equal, and that's represented by the value lambda. Okay. Here we can see this example of a Subway restaurant example where at 12, that's at lunchtime, then if you want to give an expectation that how is at the 5 p.m. or so you can get a get an idea about how much customer will be coming. And here is the Poisson distribution formula you can find in your Excel. And there are two things here, the number X, mean, and cumulative. Now, cumulative, this value of cumulative could be true or false.
If cumulative is set to true, then this function will provide cumulative probabilities, otherwise the default is false, and it provides values of.
So the default value is false. If you like to calculate a cumulative, so cumulative has a formula we discussed in our prior lectures. If you go back, like cumulative frequency and cumulative values, you'll find all those there. So this probability mass function fx is given here. Let's look at the example with this Excel file, and it says Poisson probabilities. I have that file. Let me bring up that file so that I can show you. We have week 11 and we have Poisson probabilities. You can see here, X, this is the number, function of X, that's, and we have a given 12, mean 12, and f of x is the Poisson distribution, right? And if you click here, you can see this formula. So if I click here, this enable editing, yes. So if you click here, you can see this A6. So this is A6. Mean, that's 12, that B3 here. And it is true. So it is calculating the cumulative frequency or cumulative Poisson distribution. And you can see here, this graph is symmetric. This graph is totally symmetric. So that's how we will calculate this Poisson distribution with this formula. You can see here. All right, so we need the value we want to know, that unknown. Say it's 12 p.m., 5 p.m., 3 p.m., and there is a mean. So mean is given here 12, and cumulative is true. Now, if you turn it as false, that would be the default. Then it could show a little different thing. But here they created a cumulative frequency. I'm going to share this file to you so that you can play with this Poisson distribution. All right, so let's move. We are skipping a distribution that's called uniform, and we'll be moving with normal distribution. So let's go with a normal distribution. So normal distribution, let me go back to your text so that you will get some interesting information about normal distribution. Normal distribution, right? You can see here, the normal distribution is a continuous distribution. So this is continuous. Poisson was for random. That is described by familiar bell-shaped curve and is perhaps the most important distribution used in the statistics. So normal distribution is one of the most used normal distribution, and obviously it is for continuous values or continuous variables. So that's continuous, but Poisson in case of random. And like random has as many events as you can. There is no limitation of events in case of Poisson distribution. So that's some key information you will find in your book. All right, so you can see here it's a bell-shaped curve and characterized by two parameters, mean and standard deviation. Mean and standard deviation. And in case of Poisson, we can see here, they have expected value and variance. And in our prior class, we cover what is expected value and what is variance. So that's in 81. And those are those properties of this normal distribution. It's symmetric. Mean, median, and mode all are equal. Range of X is unbounded. Empirical rules apply. Now, for this one, I encourage you to read the book for more understanding of empirical rules. So Excel normal distribution. So this is the formula for normal distribution that you'll find in your Excel file, and I'm going to show you as well. Now, normal distribution calculates the cumulative probability. And again, you can see here true. If cumulative set false, then function simply calculates the value of density function, right? Which was a little practical, which has little practical application. So more consistent result will be coming if we use as a true. All right, so let's look for this normal distribution. And you see here, the distribution of customers' demand. So it is calculating their demand. When a business runs, they always predict, say now is Christmas time is coming, right? And you will find many stores are running 24 hours. If you order something in Amazon, maybe after 1 week, they will probably now will take 2 days. If in a normal time, they will make it 4 days. So they have some assumption, and this normal distribution can help them to measure it. And you can feed those information with different parameters, right? Given to calculate for normal distribution assumptions. Find the probability demand will be at most 900 unit per month, exceed 700 unit per month, between 700 and 900 unit per month. So some of those warehouse or companies, they are thinking about that product, and they are trying to know the time and their unit to be sold or whatever distributed. It's based on the type of business. So let's go back to next slide, and it's this example in your book 5.34. Now you can see here in the first characteristics, the graph is symmetric, and you can see here in the first example, they draw a symmetric shape, and after that they're trying to find where would be the expected number of units, right? So the probability that demands will be at most 900 unit. And you can see here, the normal distribution is calculated like this. and there is the formula. So here, the upper item, right? The lower item. This is the mean, I believe. And it is true. So let me go back to the Excel sheet so that we can see this formula here. And the file is, let me find for normal distribution. I should have that file. Normal distribution. Here, see normal distribution, right? So let me copy this file for you so that I can post this in your course shell. All right. And you can see here, let's enable this. If you click here and touch, and it's true means cumulative, right? And it's standard deviation, mean, and A7. So A7 is the 500. So that's their expected unit. And the probability of, or the value of the distribution, it's all probability, right? And normal distribution also calculates the probability, but it is not the general probability. It's fit through a model, and you can see here they made this curve from this data. So if 500 unit, that's probability this, 555, 1000, then this is the probability for this. And those are those mean and standard deviation. And let's go back to the slide.
Hello,
Here.
Professor.
Yes.
Yeah, I have a question.
Yeah.
This term, probability mass density, probability
Function.
mass function, are they used interchangeably? Are they the same? Do they mean the same thing? Because at times it confuses me.
Okay. Every distribution has a so we are learning few models, right? In last lecture, we talked about binomial, right? Today we talked about Poisson, and you can see everything has a different PMF, like probability mass function. Now, we have a lot of different kind of events in our real life, right? Say for sales, for airlines flight ticket sales, right? Different weather events, like the possibility of the student enrollment, right? And we have different kind of parameters. Then which model will work for us? And that's why now again, like it's a random, it's a continuous. So most weather events are continuous. So if weather events are continuous, then we need a model that deal with the continuous variable. Is that little bit helps this thing?
Yes, it helps.
Okay. That's why we have so many different kind of models based on the nature of the data and nature of the events. I know it is little confusing because you're learning too many models at a time. And that's why I actually skip the uniform, because that could make you confused. So and Poisson, binomial, and a normal distribution are very important models, and you can use it everyday life. So that's why I'm covering all those important models. I hope that helps, but please read the book. Because book has more examples, and that will help to understand those real life aspects. That's why I'm switching between books and slides together and Excel sheet, so that you can have real life example. You can see the formula from the slide, and we can see that formula in Excel sheet as well. Thank you. All right. So we can see those 970, 750 and 100. Those are values are given here, mean and standard deviation, because we need those values to fit with this normal distribution. All right. Okay. Now we can see here this curve is this curve has talking about the demand that's less than 900. There is another example that's probability that demands will exceed 700 units or greater than 700. So exceed means over 700. So that's why it's over, right? And it's the 1 minus normal distribution. And if you deduct this, then this shape will be coming. Same way, question 3, the probability that demands will be between 700 and 900. So it's precise. It's precise. Expectation is precise, 700 and 900. And you can see this formula here. And you can find those with this Excel function. So because book has a solution, right? So I'm not running myself, but I will encourage you, please copy those columns, put it here in another sheet or another location, right? Then you can use the formula and try to use it yourself. I will encourage you to practice it, right? And I'm going to post all those files right after my lecture. All right. So let's go. There is an inverse form. So when you talked about probability, and the probability always lies between 0 and 1. And we have a complement of probability, that's 1 minus probability of A, right? Probability of complement A equal to 1 minus probability of complement probability of A. So same way, there is an inverse normal distribution formula. And if we read it here.
Suppose that we know the cumulative probability but don't know the value of x. The Excel function.
So norm, inverse, probability, mean, and standard deviation provides the x value for a given cumulative probability. So if you have a cumulative probability given, then how do you find the value of x? Now we have to apply this formula for calculating those. And if I go here in the book, see, this is detailed explanation of those things, and I will encourage you to read those texts from your book. That will really helpful. Now, here is the example of inverse, and I can see here this is given, and the minus it the same concept that we have in this complement of this probability of probability and inverse probability or complement probability of an event A, right? So let's look at this, and if you search this one, you can easily find that in your Excel sheet about this, and here is the parameter. And in that example, they already given all those parameters here. This is given, so you can easily calculate that with this. Okay. All right. Let's go inverse and see if this the demand lies here, then of course the inverse goes there. It's like if you apply the common sense, you can easily find that that inverse thing of this probability here. All right, there is another form of this standard normal form, and the formula is like this. And you can see this standard normal form, the shape comes this symmetric form. So that's the most general form of this standard normal distribution. So I'm not making it complex, right? There is a formula here normal standard deviation formula. And you can see these 1 and -1 because it is symmetry. So there is a -1 side here and there is a +1 side here. Okay. And you can see this standard normal probabilities. And so we cover four different probabilities, probability distribution in this chapter 5, but I'm going to summarize with this with few general terms so that you understand why we are using this model. So here you can see this data modeling and distribution fitting. So this thing is key or summary of all the distributions that we discussed so far in today's class and our previous class. You can see here, there is a section in your text, data modeling and distribution fitting. So when we have some event and we like to get some statistical data about our events or some forecast of events using those statistical model, we need to know the general general concept why we need statistical distribution and which distribution needed for what kind of data and practical areas. That's this section is talking about by wrapping up this chapter. So let's read the text and try to understand.
Using sample data may limit our ability to predict uncertain events that may occur because potential values outside the range of the sample data are not included. A better approach is to identify the underlying probability distribution from which sample data come by fitting a theoretical distribution to the data and verifying the goodness of fit statistically. Examine a histogram for clues about the distribution's shape. Look at summary statistics such as the mean, median, standard deviation, coefficient of variation, and skewness.
Right. So I'm not sure how many of you already know or have concept about data visualization. So when you started to pre-process data or after pre-processing data or whatever you have a clean data visualization is very important. If you see some pattern, then you can actually, that visualization help you how to proceed and which model should fit for you. Okay, so that's it is saying here, examining histogram for clues about distribution of shapes. You can also look at the mean, median, standard deviation, coefficient of variations, and skewness so that you understand what kind of model you could use. There are another important thing it is talking about here, limitation of models. Say we have some data and data sometimes has outliers and it could give you a different pattern, or we could have a missing data so that if we even fit that distribution, we may not get the desired result. So that's the limitation part. Don't get upset. Everything had some limitation. So this is the limitation of the model, right? Because not all data all the time gives us the right example. All right, so this is a general concept about when you're planning to use a model and uncertainty means limitations of the model. But when you plan to fit a model, you have to look at those measures, and that's part of data visualization and to find a clue which model will fit for your data. So here, I already posted you this airline passenger data. We calculated some cumulative frequency here, I guess. If you go in your week 8, I believe that that data has posted. All right, so sample data on passenger demand for 25 flights. And in our previous class, we talked about the ticket sale possibility with some, I believe that's in fit with binomial distribution, right? How much sale should go, and if go beyond, then you will lose or you can make money. That kind of calculation we did. Now here, if you look at this graph in passenger demand data, and you can see here, let's read this.
The histogram shows a relatively symmetric distribution. The mean, median, and mode are all similar, although there is moderate skewness. A normal distribution is not unreasonable.
Right. So you can see here, this looks like symmetric, but it has skewness, and skewness on the right side, right? A normal distribution is not unreasonable because normal distribution is symmetric. The first property was symmetric. So if you like to apply normal distribution for calculate passenger demand, that could fit this. And how do you know that? We did some data visualization. After visualizing the pattern, then we said, okay, let's fit for normal distribution. And it says the normal distribution is not unreasonable. It is not telling that it is very reasonable. Rather, it is telling unreasonable. Means it may not be good, but it is not that bad. So it's feasible. Okay. Now here, it's talking about exponential model, but we have not covered exponential model. So I'm not going to detail of this slide, but you can see there is a skewness here at the right? And it is saying that sample data on the service time is 812 passengers at an airport's ticketing counter. So let's read this slide, the text.
It appears to be exponential, but there is a difference between the mean and standard deviation, suggesting that it might be some other distribution.
Right. So if mean, here you can see mean and standard deviation. So mean is 126 and standard deviation is, what is the standard deviation? 105. So there is a quite a bit of difference. So they're saying that, and also the pattern. And we because we have not covered exponential, so we don't know the pattern of exponential distribution. But in your book, you will find that. You can have a look just for sake of knowing. And they're saying that it might be other distribution, not exponential distribution. So the idea I'm trying to give you here, that data visualization is very important when you are processing data. That's the message we are giving it. And when you visualize the data, and almost all distribution need those values, variance, standard deviation, mean. So by looking at those data, and those data will help you which distribution or statistical distribution you are going to choose for your data need. All right. So we are wrapping up this chapter 5 by covering those models. And this slide is already posted in week 8. So all are those there, but I can certainly drop those associated file in today's models. That's week 11. So I can see groups. That's wonderful. Very good. That's wonderful. I'm going to, this is an important asset for me so that I can do follow up with all of you guys, right? I can see some couple of different single names like Siddharth and Loretta. So maybe it is okay. I can tag you both together. Yes, someone has a question.
Yeah, can we have 4 people in a group?
No, I'm sorry. It will be an exceptional case, and I will decide that myself later. Is 4 is too big? Okay, I'm sorry. I cannot promise any 4 group now. I will check the class list and distribution, and then I will distribution means distribution of the group members. It's not the statistical distribution, and then I will form group whatever needed based on the odd and even size of the class. Even I know some couple of students probably will be dropping, so I don't know the combination. I have to have a detailed look in the class size first. All right. Good. Any question about distributions? I hope you get some idea about the statistical distribution, right? Excuse me. All right, so it is touching almost 7 o'clock. Let's take a 15-minute break, and we'll start our class as quarter after 7. All right. Any question for me before leaving the class, going to the break? Nope. All right. So let me, if I can pause this. All right. No worries. No worries. So see you in quarter after 7. Okay. I'm taking a break, and you should take a break as well. Thank you. All right, everyone. I'm back. Hopefully you are back too. So let's. I'm not sure if how enjoying. I hope you're enjoying this class, and if you have any question, if you are not too sleepy, you can turn on your camera and quickly say hi or yeah, good.
Hello,
I
sir.
know it's a late class and you're tired. It's a long day, right? Um, let's cheer up for last moment. I'll be here another 20 minutes and we'll wrap up the class. Okay, I'm going to introduce chapter 8 today. That's talk about regression and some pattern of the data. So I'm not going to finish up regression today, but I'm just going to introduce, talk about few things, and then we'll wrap up today's lecture. So any questions so far for me with groups or with the models we cover earlier part of this class? No? All right, very good. So let's share my screen. Good. So the group is looking good. I can see. I'm going to post it officially. I need to have a look other than my class time so that I can compare it with the class list. Okay. So let's go chapter 8. And chapter 8 is talking about trend lines and regression. And trend lines is important to understand the trend visually. And regression is a technique. That's regression also an statistical technique that gives us pattern and give us some idea of assumption. I can give you a couple of example use of regression. Say house price, right? And house price has a lot of parameters. Obviously, how big it is, that's some of the criteria. Sometimes even which area it is located. That's another factor of housing price. If the area, the house located, what is the crime rate of this area? There are so many factors. So regression is one of the thing that we apply to predict the price of a home, right? So regression is a very important and widely used model. So modeling relationships and trends in data, because all about data is to find a trend and so that we can make a decision. And that's why to measure the trend, we need to know different models. And those are statistical models. And I'm sure you're familiar with AI, means artificial intelligence. Then the next term you're familiar with machine learning. And all those machine learning algorithms. So machine learning algorithms have two categories. Actually more than that, but let's highlight two now. One part is called conventional machine learning. And conventional machine learning algorithm depends on those statistical model. So in other terms, those statistical machine learning or the conventional machine learning actually sometimes termed as statistical machine learning, right? Now another type that's called neural network. So that's a different thing. It's not with the statistics. So that's a different trend of, and you see this ChatGPT, that's AI, right? But it doesn't use this statistical machine learning. It uses neural network-based machine learning. So it's just I give you this idea why these statistical methods are so important, because we apply those in our daily life and we live in a data-centric society where decisions are made based upon or by analyzing data. Okay. So let's read this slide.
Create charts to better understand data sets. For cross-sectional data, use a scatter chart. For time series data, use a line chart.
Right. So if it is a continuous variable, then line chart helps. If this data is discrete, then scatter chart helps, right? And create charts to better understand the data. I already discussed our data visualization when you are going to process data. So I hope you can connect all those three ideas with this slide. So better understand data by creating charts. That's data visualization. Now we can see a bunch of equations in this slide, and I'm sure you have some sort of mathematical background or statistical background. You at least are familiar with the terms linear, logarithmic, polynomial, order 2, polynomial, order 3, and power exponential. Now you can see here ln, that's called natural log. It's called natural log. And by default, the base of natural log is e, and it's a fixed number like pi. Pi is 3.14, right? But if you see log, that's base 10, or could be a different base that defined by that thing. But if you see the symbol ln, it's a natural log, and that's the base of natural log is always e. All right. Now we can see here y equal to bx. Now y is unknown, x is unknown, and a and b are some constants. Okay. Logarithmic function y equal to ln x. So x and y are unknown, and this is called the logarithmic equation. Polynomial degree 2. There are two unknowns here, y and x, and a, b, c are constants, some parameters. Polynomial degree 3, you can see here x cube, x square, x, and a, b, c, and d all are constants. Power, y equal to a x to the power b, x and y unknown, and a and b are constants. Now exponential, y equal to a b power x. It's not a b power x because it's a multiplication b power x. All right. So those are those equations. I'm sure those equation is not making sense to us, but this is our challenge to learn. Now, if you go in Microsoft Excel, you can find all those equations here as well. And you can see here exponential, linear, logarithmic, polynomial, power, and last one is moving average. So we're going to see an example quickly before wrapping up. Now R square, probably this is new to you. What is R square? So R square is a measure of feet. Now feet with what? Feet with a model. Now, and this R square helps to understand an event or a data. Does it fit with linear, fit with logarithmic, fit with polynomial degree 2 and 3, or power or exponential. So that, excuse me, that idea will be given by this value R square. Now the value R square will be between 0 and 1. So it's good to know. R square will be obviously between 0 and 1. A value of 1 indicates a perfect fit, right? And all data points would be lie on the line. And the larger value of R square is better the fit. Now, we have two slides here, but let me jump from this slide to this slide. So we learned different linear different equations in this slide number 3. Oh, where is my cursor? Here, right? And we also know R square, and it gives you an idea. Is this calculation or this trend fit with linear, exponential, polynomial, whatever? How do you know? By looking at the value of R square. At this point, consider those are those given values. These are given values, right? Now, we can see the unknowns y and x. And if you replace this x, you will get some values of y. And by calculating, you will getting R square equal to 0.6. So what is the best fit here? The highest value of R square is 0.928. This is the highest. So say if you go for Excel trend line, then you will find polynomial degree 3 has the best fit because it has the highest value of R. At this point, consider those values of R square are given just to understand you the nature of the data fits with what kind of equation. All right. And if you look at the least fit, that's the logarithmic, right? So just don't go too deep at this point. We learn about different equations and those are actually fit with some data. And Excel has all those functionalities. And now how do you know this data fits with what kind of mathematical functions or equations? And if we know the value of R square, then we will know that this goes with polynomial, linear, logarithmic, or exponential, whatever the case. Now let's jump in slide 6. You can see here, there is a data, and this data is price sales data. Let's bring up this Excel file for you. If I go in the example, that's better to understand. Where is this? It's called price sales data, right? Price sales data, yeah, I have. Okay, you can see here this price sales data. And let's draw a graph ourselves. So I select this and insert, and I choose scattered chart, and I choose the first one. And you can see here is the same graph we just redraw. So price sales data. Now, if you click here in this plus sign, you will find trend lines. And if you click here, it's automatically fit linear. But say if I choose to exponential, right? Or linear, or 2 period moving average, more options. So there are so many options you can see, same as your slide number 4. You can see all those functions. So you can easily see all those. And by default, you can see here, if you choose linear, right? And polynomial, its best fit with by default is linear, right? So I'm showing this data to you so that you can play with that, and you can see this value R square is 0.83. So it's say higher value that's close to 1. So obviously for this graph, it fits with linear trend. So this data has a linear trend. Now I can give you some example. Why it is linear, why it is not exponential, right? So say I can give you a couple of examples. Say online shopping trend. If you look at the online shopping trend, let me just show you some exponential versus linear growth. So let's talk about growth. And if I choose images, I'm sure I can give you something, right? Probably this is a good graph for explaining exponential and linear, right? I'm just choosing a random graph. If it is linear, then you will see a steady growth. That's linear. So steady growth, right? But if you see something that suddenly grow, then it's exponential. And I can give you a real life example that's trends in online shopping versus in-store shopping. And if I go in images, just I'm trying to give you some trends line. I'm sure there is. Okay. Let me go in Google. Probably I'm not getting enough information here. So let's go. Shopping pattern, pandemic versus post-pandemic. And if I go for images, I'm sure. Okay. This graph will help us to understand. So in this graph, we can see here, page view and order. Now, you can see here, those are probably monthly data. I don't see the year. You can see this page view data, the green one is going linear. So it is growing linear. But suddenly this order goes up here. So the traffic growth is steady, but order growth is suddenly high. So that's 15 exponential. Now why? Because there is a big sale event going on. So I hope those two examples helps you to understand how do we understand the pattern. All right. And one of the measures that's already mentioned in this slide is knowing the value of R square. And at this point, those values of R squares are given. Okay. If it is 9, means close to 1, then this is gives us the best fit. If the least value is least and close to 0, that's the least fit, is not well fit. Okay. So I see this example here for sales data. Also, there is a historical crude data. And can you tell me, by looking at these, we talked about exponential and linear. Can you find any relation on that? It's obviously linear because the growth is steady, right? There is no sharp change in this graph. And I have that Excel file as well. Week 11, so crude oil. Okay, you can see this crude oil data, and it gives data from 2006 and 2007 for 12 different months. And you see the growth is linear, okay? And if you go here, and if I just try to make this insert graph, and let's go for line, maybe this, okay? And if I go here and for trend, you can see this is automatically chosen the linear, right? It's automatically chosen the linear pattern. But if I go exponential, I don't see any, yeah, see this, if I change those, no, it's best fit for linear, for sure, right? So that's all about I want to talk you today. I'm going to cover regression in our next class. So let's wrap up quickly. In chapter 8, we are going to talk about trend lines and regression to assume some future values or price or events, right? So you should be familiar with those mathematical functions. We call it equations. And in Excel, you know where are those trend lines now, right? So if you have a data, then if you draw a graph, then you can play with those different trends lines so that you know where it is fitting best. All right. So that's all for today. I'm going to start talking about regression in our next lecture. All right. Any last question? And thank you so much for listening me. I know this is a class of mathematics, and it is very difficult to keep students' concentration when we talk about math for longer time, like 2 hours. It's not easy. But I know you are a very patient student. I appreciate that. And I can see you are taking things seriously, and I can see the reflection in the quiz too. All right. So any question, feedback? If you don't have, yes, Anthony, you are trying to say something, I guess. Or someone trying to say something.
Yeah. Regarding project, so when is that submission date, or there's a due date written, but do we have to give a due date or before we can do presentation? How it will be?
No, you will get like very end, like say last day, because I need couple of days, at least 3 days to upload the grade. But I will give you flexibility to the very end. But let me tell you, if you have any complaint, we can resolve that in that time. Don't worry, you will get plenty of time. Okay.
Yeah. Yes.
Wonderful.
What we have to do as of now, we have to wait for the instruction.
Yeah, please.
Okay.
Yeah. Allow me a little more time. Oh, let me post the material before you go so that you can see it, okay? Siddharth, I can see you raised your hand. Is it resolved already, or you have still question?
Yeah, resolved. I have.
Okay, very good. Thank you. Let me share my screen so that I can post the material, okay? Let's go model, and let's go in here. Let's go in week 11. And let me go add material, right? So do you want me to post the slide again? I can post it again, no problem. So files, where's the file there? Chapter 5, statistical models. And I need to drop it here. Okay, so now save. Let me try. At the beginning of the semester, I tried to upload multiple files together and I got caught and didn't work. Let me see Excel data files. If I can upload all those files together, then it would be great. If not, I have to upload it individually. I have quite a bit of files today. What is that? Here. And I need, okay, one up. Excel data, week 12. So let's start with one. Homemaker. Now normal. This is Poison and final price cells. Let me see. Hopefully we can add all those files together. Save and return to the course. No. So I have to actually edit those individually. Okay. I can make a zip file. Okay, good. I can actually create a zip file and post all those files together. Okay. So Poison, normal, homemaker, crude oil. That's all I guess I have. 1, 2, 3, 4, 5. Okay, good. I have to compress as a zip and say I name it week 11 Excel files. Okay, so that we can do that all together in one upload and one download. Files and week 11 Excel files. Excuse me. Excel files and here. All right. So now you all have those data and I can do one thing as well. Added this. Did I delete the slide? Oh my gosh, okay. Chapter 5 is statistical model. Okay. And I should give this Excel file. Save. And I go in week 11. Good. And do last file I'm going to give you so that you can read yourself. Chapter 8. Trend lines. And I'm going to give this week 11. And could you please give me a feedback that you can see and download all those files? If you refresh your browser, files should be available by now. All good? Very good. All right. So thank you again. Thanks so much for showing off and attend the class. It's